Okay, so welcome to this edition of the Robotics Institute seminar. It's my great pleasure to introduce Aakash Sinha. Let me give you a little bit of background on Aakash. He was born in 1979, so you can calculate his age. In the northern part of India, but quickly at the age of 3 or so, his family moved to the Delhi area where he grew up and attended the very well-known Delhi College of Engineering, recently renamed Delhi Technological University. Excellent top-level school in India. When he was a senior there, he came to CMU under the sponsorship of Raj Reddy, who many of you probably recall was the founding director of the Robotics Institute. One of the other founders, Arnhel Jordan, is here today. My pleasure to introduce him as well, those of you who don't know him. During that summer and about half of the subsequent semester, Akash worked with me on a display technology related project in which he did excellent work, went back to his home university, finished work for about a year for an outfit that he says he thinks designed and built the first single board computer in India. He's hedging his bets just in case someone else did it first, but he's pretty convinced it was the first one. Then came back to CMU and did his master's degree here, working primarily for John Bears on the kinematics of the machine that was originally called Spinner and that probably you now know as Crusher. He then, as is typical of students coming from overseas, took a job doing the optional practical training that students who are here on student visas are allowed to do. That turned into a job with a company called Perceptech that some of you may know. And after a couple of years of that, he had the good fortune to run into Rod Brooks, who had a little tiny company called iRobot going at that time, and hired Akash. He worked for a couple of years in the technology side, then decided he also had an interest in business, and started getting involved in that, had an idea for an iRobot branch in India, went back to India as director, founding director again, of iRobot India, did that for several years with many interesting projects that he will, some of which he'll tell you about, and then spun off a few years ago his own company called Omnipresent, which has a small presence. It's omnipresent, but only a small presence in the US, but a large presence, a relatively large presence in the robotics industry in India now. Has about 8 people working for him and many interns, he says, who are very good. And based on the small sample of one who came and worked with me for a relatively short while this summer, I have to say I'm impressed because this student honestly got more done with more breadth and more depth in the few weeks he was with me than a substantial number of master's students I've had in the company. So if all your staff are that good, you're in good shape.
Well, we definitely make them work hard.
Working hard is good. Working well is better.
Yeah.
Okay, so with no more ado, I will present Akash.
So thank you, Mel, for that really brief introduction. First of all, very excited and honored to be back at my alma mater. As you know, I think I've already just put it over here. I really feel at home being here and just going through all these halls. And in fact, the same hall I remember attending so many guest lectures. I never quite imagined I'll be, presenting one here as well. And so as Mel told you folks, I'm alumni from here. and worked with Mel, with Raj, John Bears. I also used to participate in ice hockey. There was a robotics institute ice hockey team. I don't know if they still have that, but I remember I almost, I fell very badly a few times before I eventually learned. But it was a great experience being at RI. So, but today the reason I'm here is essentially not so much about me, but really about you folks, and my real purpose here is to motivate at least some of you folks to be able to take up entrepreneurship, and especially entrepreneurship in robotics. And the way our company started, we started with practically zero money, no investors, no great environment, and so we've learned a lot of lessons coming out, how to bootstrap, how to survive, and so I want to be able to share some of that. And then finally, I want to be able to brag just a little bit about what we've been doing. And so that's how my talk will be organized. May I ask before that, are there any undergrad students here? Okay, lots of them. Very good. Does RI have a program in robotics at undergrad?
We have a second major that we just started recently.
Good. And how many master's students? Good. And PhDs? Okay, good. So we have a good distribution. So I'm really excited that so many of you have turned up. And before I get into the things that we've done and how we came around doing those, let me just talk very briefly about me, although Mel hasn't really left much on that. But this is kind of my past lives. I started at CMU with this UGCV crusher, which at that time it was called Spinner, and this was basically my first robot. The first robot I get to work on was a 5,000 kg robot, and but a lot of stuff to learn. Then at Perceptech, I was part of the DARPA Grand Challenge team. We did finish in top 10, although we are still behind CMU. Then I got to work on Yamaha RMAX as a UAV platform at Perceptech only. And eventually I worked at PackBot at iRobot. So probably most of you know what PackBot is. It's one of the tactical defense robots. So that's sort of what my work experience has been before I started Omnipresent. And as Mel spoke about, I got some good recognitions through that work. And it is actually especially very important as a startup. If you're recognized, that's a very good thing for you. So, and I was fortunate enough to get some recognition. So there's a Lockheed Martin program in India to select top 30 innovations of India. So one of our robots was selected in that. And then you have the DARPA Grand Challenge, as you know. Also, Enterprise Asia selected us as the Young Entrepreneur of the Year, Asia. And then MIT's TR35, which is researchers under the age of 35, 2013. And then at iRobot, they have something called Rock Award. They give you a rock and say, you rock. It just has your name. But I felt that if I wrote it that way over here, it'll probably not it'll look strange. So I just wrote outstanding employee thing. So anyway, after all that, what are we doing currently at Omnipresent? I'll just show you again some of the products that we're doing. So we call ourselves Omnipresent, saying that we'll build robots for land, air, water, and space. We think of ourselves as like a software company who can develop software for anyone, from bank to airline to. So we think all the robots as just different types of robots, whether they're for space, for land, for air. So on top you see Hansa, which literally means Swan, and that's our fixed wing UAV. It's made specifically for one of the defense tenders, which has very specific requirements that I'll discuss in a little more detail. And then on the bottom you see tactical UGV Angad. Then this is made for DRDO, which is similar to DARPA over here, and it's being used for bomb disposal. And then we have a river cleaning robot. So I know rivers are actually very clean over here, but in India they're getting quite dirty. And so we came up with this idea of cleaning rivers using robots. So this is still sort of under development. We've tried it in Delhi's Yamuna River, and it's still ongoing on that. Apart from that, because I didn't have enough space here, we are also part of India's space program for Moon, which is called Chandrayaan-2 mission, the second mission to Moon. And we have developed a navigation module for that. And so eventually we take pride in saying that in 2 years' time, we'll have something that will be on Moon. So something that was developed at Omnipresent will be at Moon. So that's about the products that we do. Very briefly about our founding team, it's basically me and my wife. When we started off together, we have studied together from undergrad. We worked together at iRobot, and then we said let's start our company together as well. And so we both have a good background in robotics, which sort of helped us. Obviously, we've had a good fortune of having Dr. Reddy on our advisory board. So from time to time, we're able to get some good advice from him. And then we have our Vice Chancellor from Delhi Technological University, who's also on our advisory board. So that's pretty much what our team is, at least the founding team. And of course, there's a larger team that supports us, and then an even larger team of students who actually work with us. So I'll get into our story. Before that, let me attempt to play a video of one of our products so that it just doesn't get, oops, let's see if this will play. Okay, looks like it's playing, or is it? Okay, all right. So what you see over here, we had this requirement from Indian Defense to develop a UAV that won't require a runway either to take off or to land, will have an endurance for at least an hour, will be able to carry a payload of about 1.5 kg, and should be able to detect a human being from 1 kilometer height. It should also be able to operate in about 5 kilometer range of control. And so essentially this is a demonstration video of that UAV that we're developing. So you'll see how it's hand launched. Because it's a little heavy, you actually have to run a little bit to launch it. And but then usually once it's in the air, it flies quite stable. So you can see that we have to keep it very lightweight in order to be able to get the 1 hour endurance. But I'll just let you watch the video for a few moments before I interrupt.
Is it electrically powered? Or
Yes, it's powered by lithium polymer batteries. We can go up to a height of about 1 kilometer, and can run on autopilot as well as manually controlled.
You mentioned detect humans at 1 kilometer? Is that
Yeah.
the vision? Or?
Oh, well, no, there's really no advanced vision processing in it. It's just, that there is an operator who's watching the video. So, you should be able to make out a human being from 1 kilometer. There's no advanced vision processing. We have a very basic target tracking that, you can actually click on the laptop and try to track a simple target. But, so you'll see the landing piece right here. We basically stall the plane speed to a very slow speed, and then eventually it just belly lands. I hope you can see it in the picture. So it just belly lands gently over a rough field. And so, a lot of it, as the question you raised was very relevant. But a lot of things that we do are sort of so market driven. If they don't want any more smartness than what they need, we'll probably not offer them either. So that's the video of one of our UAVs, and I have some more which I can show if someone is interested after the talk. I can show video of all of our products. But that's about what we do and what we've been doing. And now I want to move to the next piece of entrepreneurship, unless anybody has any questions regarding this.
How much time did it take you to develop this?
We've been working on this for last 1 year, at least since we knew that this opportunity was there. Before we developed this, we had developed a quad rotor UAV, so we had some experience in that. And but this came out as a very specific requirement.
Is this from off-the-shelf components, or it's something specialized?
Some of the things are off the shelf. For example, the engine, the battery, the radios, cameras, all the sensors are off, even the motors. But the aerodynamic design is ours. The autopilot is ours. The control software is ours. But most of the electronics stuff is off the shelf.
So there's obviously an enormous industry and hobby community in RC aircraft.
Yes.
So the first question that comes to mind is, why not buy a high-end item from the hobby community and add to it the little bit of smarts that you need for autopilot?
Well, the reason is that when they since this is for a specific defense tender, they come out with very specific requirements, and you could try attempting with that, but we've seen that approach is usually not successful in the defense tenders, because they have some very specific requirements, and it might be hard to find everything that will do that. You can probably find the engine, the electronics, but I'm not sure about the autopilot. Batteries and stuff you can definitely get off the shelf. Yeah.
So you mentioned you're making this for the defense. So do they have is this with mil spec?
Well, it's not. It doesn't quite have mil spec, but they have their own requirements. They have a requirement for operating temperature. They have a requirement for the amount of shock it can take. So all those things you have to incorporate. So should I go ahead? Okay. So, all right. So we are on the next part of the talk, and I've titled it Robo-preneurship. I'm just presuming that most of you are interested in robotics entrepreneurship. But even if it's a different field, a lot of what I speak about would still apply. And but I'm particularly excited about robotics because from what we have experienced, there seems to be a lot of growth, at least in some specific market segments. So not all kinds of robots are in demand, but there's definitely a big market for some specific type of robots. But before you even do that, you might want to ask that question, why should you become an entrepreneur at all? And, I put it this way, why not? We've seen people world over, and especially in United States, whether it's the Zukerberg or Gates or Jobs or whoever it was, they've started their companies while they were in college. And there's a big advantage of when you're in the university, you have this. Okay, I hope you have some time after whatever research work your professor gives you. But apart from that, you also have less pressure of getting a job, earning, making money. So it's a very good time to actually if this is what you really want to do in your life. If you want to become an entrepreneur, then I think the best time is in the college. While you have when you can take a little more risk when you are in college than when you are doing a job after that. And then again, being an entrepreneur, you probably don't have a boss. Well, your customer is still your boss, but in some sense you don't have a boss. You can have limitless growth, or at least an option to have limitless growth. So those are some of the key things for being an entrepreneur. And especially if you talk about robotics, I think it's going to be the next ubiquitous technology. So for example, currently the laptops like these, or your mobile phones, internet, these are the sort of the ubiquitous technologies. Everybody has them. And what's going to be the next ubiquitous? We think it's going to be robots. You'll have robots helping you at home in fighting wars, helping you guard your buildings, or just about every work you will find that robots are there helping you out. So that's one of the great exciting things to think about robotics. So as I said, we've seen some very good market trends. And the biggest market that we see in robotics is UAVs. It's huge. And according to some estimates, it's going to grow at something like $400 billion worldwide. And so UAVs is a great space to be in. Whether in India itself, we've seen tenders worth over $100 million that have came out in the last couple of years. And so a great market to consider. If you're thinking about UAV, but when you make a UAV, don't just make a hobby UAV. You must think about a good application. Maybe it could be defense, it could be agriculture, firefighting, whatever. So, but it is a market that is growing. Medical robots is another. So that's another field to look at. And then another market that's going is the market of educational, hobby, and toy robots. So if you're into that, and we've got one of our educational kits that I'll just demonstrate towards the end of this presentation. So I'm going to talk a little bit about what really is, according to me, or what we've learned about entrepreneurship. So when you decide to be an entrepreneur, there are essentially 2-3 things that you want to start with. And even if you don't have any money, that's okay. That's not the prerequisite requirement. What you really want is an idea that's marketable, sellable. You want to have a good team, a founding team. Don't start alone. It's a lot of work to do. And then you want to have an execution plan, and that also consists of 2 things. One is how you will develop the product, and the second is how you will generate money out of that product. So those are the things that you want to keep in mind when you start. And I'll just get into detail of a little bit detail of each of these. So when you think of an idea, don't just solve the problem of your next door neighbor, or don't just solve the problem of your just a few people around you. Try to think of a large market. Always try to address a large market, and that is important, because a lot of times entrepreneurs make this mistake of not going after a larger market. Even if you have a small share of the larger market, you're probably better off than trying to develop a very niche product for a very small number of people. And then always try to think of an effective solution. Everybody wants a solution, and so unless your idea, if it can't convert into a solution, it's of no use. You must find out that who else is doing it, what makes your idea unique. Because if you're just doing whatever everybody else is doing, then there's no point trying that. So just getting to team. So if you have a good idea, think about a team, and never start alone. It's just so much work to do alone. So you want to find a good founding team. And a good founding team is always of people who can trust each other, So maybe it could be your best friends in college, or maybe even your spouse, as in my case, or it could be people you've known for a long time. But when you start a business with someone, you really want to be able to trust them day and night. You must have a team with complementary skills. So if one of the guys is a good techie, maybe find someone who has more of a business side, and that's going to help you in that. And then, of course, you need a lot of energy, fire under belly to be able to do. And very important, get advisors and mentors. It's important that you find people who have taken this path before and could pre-warn you or guide you before you make the same mistakes. So that's about the team. And then if you found the team, think about the execution. And as I said, execution essentially has two pieces. So the first piece is about figuring out how will you implement the idea, how much it would cost, how long will it take, how you're going to sell it. And if you break it down, it becomes into two different pieces. So there's a product process, there's a way in which you develop your product, and then there's a business plan or a revenue model. And a lot of us folks who are very good on the technology piece, like most of you folks are, often get the product process done, but the revenue model is something they pay less attention to. So you must figure out if you have developed the product, how are you going to generate any money out of it. So that's sort of very short advice from me on entrepreneurship, but let me talk a little about what's more unique when you're doing business in robotics. So there's some positives and there's some negatives. And the positive piece is that it's very exciting, working on it day and night. If you can work day and night in your lab on one of those exciting projects, you can probably work on the business idea as well. The growth rate is very high, at least in some segments, as I mentioned. So it's a good field to be in. The negative piece is that there's a lot of R&D cost involved. So how are you going to finance that cost? Especially when you don't have any money. And then it's difficult to find people with right skills. And even when you find them, they'll be expensive, or they'll be you might find it difficult to retain them. So on all these issues, I just want to briefly bring out Omnipresent story, how we went about this and what got us started in this direction. So, we started essentially in US with an SBIR program. Does anyone know what's an SBIR program? Okay, so let me just call it very briefly, tell you very briefly about it. If you're thinking about starting a business in US, and then SBIR is something you must know. It's called a Small Business Innovation Research Program. And essentially what happens is that you can apply to these SBIR programs and you get something like 100 grant to survive for 6 months to develop a feasibility report, or sort of a very basic prototype. And then once you've done that, you could potentially get a phase 2 that would be of the order of $1 million. And the phase 2 will help you survive maybe for another 2 years, but more importantly, it will give you the opportunity to fail and to learn without having very hard deliverables. So that's sort of what got us started here. And then I met our mentor Raj Reddy over here, and I told him about this, and he found that he told me that there's a similar program that you can do in India, which is the DRDO's funding program. So we were able to get some funding from DRDO in India, and eventually we got 2-3 projects from there. So we basically moved our operations over there, and that's another thing you might want to consider. You might see that in a lot of other emerging markets there might be more growth happening than the amount of growth you're seeing over here in US. We practically made no money for a year, and we survived on that time, and I'll talk a little bit about how we managed that. But that is something you have to be prepared. If you start as an entrepreneur, you should be prepared that you're not going to make any money for at least a year or maybe even more. So through this journey, we learned quite a few good lessons that I'll just talk a little bit about. So the first lesson we learned was that get a cash cow. No matter what your business is, maybe you want to make a truly intelligent robot that everybody will use at their home. However, in order for you to be able to finance that, it's going to be extremely difficult to find an investor. So you have to find a cash cow. So maybe your cash cow could be doing a weekend job, running a workshop, doing something that is much more easier to do. Maybe it's not your main business, but it just generates enough cash flow for you to be able to finance yourself. Another example of cash cow is an SBIR program that you could do. So that's very important, because initially you're not going to have any money, so you must find a way, a secondary way to generate income to finance your business. Don't try to do everything yourself. We found it very early. So train people, make them your right hand, in the sense that when you become an entrepreneur, you're looking after the business, the technology, the sales, the marketing, all the pieces. And eventually it's just going to get too much for you. And so you want to find a good, someone who could be your right hand. However, don't get out of the picture completely, So it's important that you still stay the left hand, So you're still involved, you take the decisions, but you train other people to be able to do that. Then, very important lesson that we learned hard way. When we started Omnipresent, we felt that, okay, I'm from Carnegie Mellon, I worked at iRobot, and blah, 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 so I'm going to get investors, and eventually it's just going to be great. And so we ran after at least 20, 25 investors. We wasted a lot of time. Eventually we realized that investors, and some companies do get investors, but what I was trying to say was that as a startup, if an investor is interviewing 500 companies, they'll probably select 1 or 2 out of them. So the success rate is like 0.5%. And eventually, when you grow and you bootstrap, and 99% of companies bootstrap, but when you bootstrap and you grow, then investors will come running after you. So how do you finance again initially? So it's the 3 F's: the friends, family, fools. By fools I mean people who are just as foolish as you are to believe in your idea. So they're not literal fools, but You know, if you believe in what you're doing, maybe you'll find other people who believe, you know. Maybe someone else is excited about making a truly intelligent robot and he has a lot of money. And he really just wants to give it to someone. And then SBIRs, or, you know, wherever you are, you know, your government program, and, you know, wherever you are, you can find one of these. And, you know, forget the investors, you know, at least initially in your startup phase, don't even waste time after that. Eventually, when you've started generating cash, generating revenue, maybe that, you know, then it's a good time to go after them. Now, that's another important lesson we got. You know, when our company wasn't really working well in US, and we met Raj Reddy, we told him about this. He gave us just one small piece of advice about, you know, create your cash cow by going to DRDO, and you know, he was eventually able to give us some good contacts in there. But that one piece of advice, you know, got us started in the right direction. You know, maybe we would have taken a couple years to figure this out. But for somebody who's already seen this, who knows this, they can probably tell you, and you will probably not waste a lot of time on that. So it's very important that even if you are very confident about your idea, get a good mentor. And a good mentor is someone who has been on that path and you know, understands those challenges. But very important to get a good mentor for startups. And then eventually the last lesson that we learned was about our employees. You know, when we initially had employees, we had practically no money to pay to them, so why will they work for us? But we realized that we can still keep them motivated. You know, if we take really good care of them, you know, they'll take care of our business. And the way we were doing this was that initially we started with college students. So, you know, we started them as interns, and even though we were able to pay them very little stipend, we helped them do what they were, you know, motivated to do. So, for example, some of them had plans to learn something in computer vision, so we helped them in that. And then we also told some of them that if you do a really good job, you know, I would be happy to recommend you to Carnegie Mellon. And that also motivated them. So, you know, it's just, you have to find a way to motivate at least your initial employees. And once they realize that your company really cares for you, you know, if you, at least when your initial founding team, once they know that I or, you know, whoever their boss or CEO is really cares for them, then they will work for you, even if they're, you know, not being paid very well initially, even if they are to miss their own work, but they'll be very motivated. And so that's very important to realize, you know, initially. So that's sort of, you know, what my take is on entrepreneurship and on the lessons that we learned. If there are any questions, you're welcome, or then I'll move to the next section in which I'll introduce one of our educational kits. Oh, yes. How did you recruit?
Suspected.
Well, okay. So, should we move to the next?
How long does the whole SBIR process take?
How long does the SBIR process take? Okay. So the way it works is that the first phase. If you, you know, when you apply online by the time you get money in your hand, it's probably around 4 to 6 months. And once you get that money, the money is there with you for 6 months, and the amount is usually $100,000 or close to that. And then after 6 months, you apply for a phase 2. And then the phase 2 will be $1 million for 2 years. And the good thing is that most of the time it will be, you know, all you have is every month telecon with your government customer, and you just tell them the progress you're making. So there won't really be any hard deliverables, you know, so you will have some room to fail, and that's the good thing on SBIRs. The other thing about SBIRs is that the team leader should be a U.S. citizen or a permanent resident. So, you know, for folks who are not U.S. citizen or permanent resident, they can always find a partner on that. So that's about the SBIRs. Yeah. Go ahead. Yes, please. What was that? Okay, I didn't turn that off. Am I out of time, Mel? Is this some autonomous project going on? I know you're good at sensing and all that.
I think someone has created a wireless control to access that. The switch is over on the left.
Okay, let's see, where is that switch?
It all works from here.
Okay.
That all works.
It usually does this after it's been on for hours and hours and hours, not after half an hour.
Okay. I guess it's just telling me to.
I've got it.
Well, anyway,
Projector went into cool down mode.
I'm very much towards. I've already spoken for 49 minutes. I don't think so.
Yeah, more like 40.
Okay.
It's supposed to do this after 4 hours.
How much time do I have? 20 minutes?
Yeah,
Oh no, we want to have at least 10 minutes for questions. Okay.
This is, sorry.
Okay, no problem. So is the presentation going to come up? Okay. All right. Go ahead with questions till then.
How is the robotics market in India? Can you tell us more about
Yeah, so defense robotics is definitely coming up, especially UAVs. As I was mentioning that we've seen tenders worth $100 million in last couple of years. And I've been told that there are newer tenders that would be worth at least $500 million that are going to come in next couple of years. And so we're hoping that we can, you know, sneak a small piece of that.
Do you know what the competition is?
Yeah. Well, so there are a couple of companies from Israel. There are a couple of companies. I think there's one company from US. One of the reasons some of the US companies don't compete there is that the pricing, you know, eventually, even though the tenders are very high value, they tend to go at a very low unit price. And so that often makes it difficult for big US companies to compete. Then there are at least, apart from us, at least there are 3 more Indian players that I know are over there. That's about it. I think there are this tender for which we are bidding, there are only 8 companies that got shortlisted worldwide. And so we are probably the smallest company on that list of 8.
So don't the academic institutes compete for this money, or it's just companies?
No, this is like a direct defense tender.
Okay.
So this is usually not really open for academia. However, there are other programs. So for example, if you are associated with an academia in India, then just like SBIR or you have another program called STTR, no, which is for academia. So there's a similar program for academia in India where you can get about $50,000 grant to academia for developing, whatever project they propose.
So SBIRs, I think, always allow and sometimes require a university partner at less than 50%.
Not SBIRs, but
So
the
some-
STTRs do.
Well, I think some SBIRs do as well.
Okay.
Maybe they don't anymore, but in the past
Okay.
they did. And the reason to mention that
Mhm.
is those are frequently good vehicles for university
Yes,
spin-offs.
yes. Oh,
Because
yes.
someone's wearing 2 hats, one on the university side and one on the
Right.
company side.
Right. Absolutely. Yeah. Go ahead.
So how about protecting your IP in India, and is it effective?
Very good question. Well, it's IP is an issue where especially it's sort of more difficult to protect it in India. Nevertheless, it's a good idea to file. Whenever you have a good idea, it's an even better idea to at least file for your IP protection. Even if you don't get the patent granted, at least your priority date is set. What could happen is, if you don't file for one, is that someone else will file, and then they will come to you and tell you that you're stealing my technology. So that's a pitfall of not filing an IP. But a lot of people do wait before filing, because they also think that if we go and file for IP, because when you're filing an IP, you have to disclose the invention. And so once you've disclosed the invention, you might open avenues for it to be copied. So it's a decision that you have to take. My hunch is that I would file for an IP once I have assessed that this product has a market and I'm about to launch it. Then I'll probably file for the IP. And then, if I'm still developing it, then it's probably not a good idea for me to disclose the invention.
How much does it cost?
Okay, well, I'm not a IP attorney, but well, in India or in US? It could cost you, the whole process could cost you at least 1 lakh per invention, $2,000 per invention, approximately, depending on the lawyer you get. I don't know. Some of them will charge you more. Yes, please.
When you're doing an SBIR, do you have to give up equity?
Do you have to?
Yeah, and if not, at what point would you suggest giving up equity?
Equity? No, on SBIRs you don't have to give up any equity. SBIRs are more like a program from the government to encourage research in small businesses. So it's the money that's coming back to you because you've paid taxes. So there's no equity that you have to give up on that. But yeah, eventually when you are seeking an investment, then yeah, depending on how you value your company, you might want to do an appropriate dilution of equity. But I would say it's probably not a good idea to give up equity up front. Yes.
Seems like a lot of the robots are military contracts, but how have you gone around looking for commercial applications? Because my impression is a lot of robots have amazing capabilities for very specific military purposes. But not
right, and in our case, it's mostly been that we saw that there was a market for them, so we went after that. It's just that we there is a market for commercial as well, it's not that, but we saw that there was an immediate market for these, and so we went about these. But there's definitely just almost as big market for commercial robots, especially if you can make a robot that does all your household chores, there's definitely a market for it, or even in education and hobby, there's a a big market coming up. Yes.
So, like the example that you mentioned about a robot that does household chores, but in place like India, do you think there's still a market for such a job because of people, so many people willing to do those jobs?
Well,
and I talk about that in other fields also, even mining. Mining
right.
industry is big.
So considering that you can get a human being to do the same job at maybe a lower cost, but I still think that there's a market. You have to also understand that India and also China, if you look at that region, they're big, huge populations, and in that huge population, there's a big chunk that have a lot of money. So we found in our survey that there are at least 20 million families who can afford, what we call a Class A family, who have a disposable income of almost more than 50,000 rupees a month. And so, we felt that in this class there are people who are, for example, if you see Mercedes-Benz is doing well in India, BMW is doing well, big LCD TVs are doing well. So the market is there, but it's not that you'll be able to sell it in the entire India. You're probably looking at big cities, a segmented market, but because the population is big, you still have a 20 million people that you could go after. Yes?
So robotics is a very technologically advanced thing. When you approach a customer, and if you're a startup, how is their attitude towards having trust on a startup to deliver such a high technological item?
That's a very, very good question. And when we first went to DRDO and we told them that, look, we can make this robot for you in 6 months flat, just give us the money. The first thing they told us was, this can't even be done. This can't even be done in India. We don't have the technology at all. And so yeah, the trust is going to be very difficult for an initial startup. And fortunately, for the first break, we had a good recommendation from Raj Reddy saying that these guys are good, if you give them an opportunity. But the important thing is, once you get your first break, you really want to do very, very well to your first customer. You want to do it so well that that customer then becomes your marketing guy. He's going to go and tell 5 other people that these guys were amazing. Even if you have to lose money on your first customer, it's very important that you do very well for them. And I agree that getting the first break is kind of difficult, but once you get that, don't ever mess it up. If you spoil your brand in your first break, if you get $1 million and you just buy a Mercedes and a villa, or or just get a trip to Caribbean, you spoil your brand completely. And so that's something you don't want to do. You want to make sure that at least your initial customers are very well satisfied. Okay, any other questions? Yeah, I'm just coming to that now. All right, we'll have more questions towards the end. So I'm going to introduce, I spoke so much about defense robots, but let me tell you, an experiment we are doing in educational robotics. And this is targeted specifically to college students and even school students. What we did was that we went to school students and we gave them a challenge with our kit, told them that you have 30 minutes to make it. And in those 30 minutes, we are going to train you for 15 minutes, and then you'll make it in 15 minutes. And so we've had some good success, at least with what we've started. And our eventual plan is to make it even more easier. So I know at CMU, when I started robotics here, we were told about a sense, think, act paradigm. So there's sensors, there's thinking piece, there's action. And I also like to think there's another module there, which is communication, because almost all robots need communication and control. And so what we tried to do was that the interfaces between, when you have to connect the thinking module to sensing and to the action and the communication, we want to make those interfaces completely plug and play, so that you don't waste any time making connections, and even the programming part, we try to design so that, even for someone who has no programming knowledge, but understands the algorithm, is able to design those robots. So we started with that goal, create any robot, 30 minutes. And by creating, I don't mean that, the robot will have all capabilities. But you will create the platform, which will be programmable, usable, and you can eventually develop it. And we must do it at a very low cost. So that's one of the specific features about the market in India. Everything has to be done at a very low cost. And so that's one of the things we have to keep in mind. And with one kit, we are targeting that we can develop a UGV, a UAV, humanoid, just any kind of robot. It can use the same set of hardware and software interface that we provide. And so what we started first, was with one of these boards that we developed. And it's on these. And you can take a quick look at it. Let me see if I have the power on that. Has anybody worked on a Arduino platform or Atmel or AVR? Okay, some of you have. So what do? You use an Arduino, maybe motor drivers, and okay, I hope this works. No? Okay, good. All right, we'll just leave it somewhere, or maybe for you guys to do around. Oh, but it will fall down, so it's not somebody will have to guard it. Oh, great. I'll just demonstrate it here. This is much easier. Okay. So, well, I hope it's doing some sort of obstacle avoidance. But anyway, the idea was that we can plug in almost any sensor on the board. You don't have to make any custom connectors. So we can plug in 6 DC motors. There's DC motor drivers. And let me actually play the video that would make the job easier for me. Oh, well, where are the pictures? Okay, so there's an effect. Anyway, so, boy, I didn't really want that, but I think one of my students made this slide. So, so anyway, so we've combined 3 motor drivers on this. We've combined 2 power regulators so that we can power up to 6 motors. We can do a 6-channel RC controller. We can do IR, sonars, ultrasonic, tactiles, DC motors, brushless DC, servos, name any. We've got them all. And then, as I said, and we provided a 3-pin bus everywhere so that you can easily connect any of the sensors. Then we also provide independent power buses so that there's always enough current, even if you're running 6 motors simultaneously. So, as I say, obvious, the advantages are obvious. You can develop something in a very small time. We are also developing a programming interface, which I can show you because it's not ready, but we've done a completely GUI-based programming interface, which which allows you to essentially select any of these sensors, and then based on whatever the sensor data is, you can send an appropriate command to the motor. And so what it does is that you can you'll be able to code without coding. So we've done a real-time experiment in our lab, and let me play this video. Hopefully it plays. Does it? Okay, all right.
In just 30 minutes.
And you don't need the audio. I'll actually just speak through it. So we did an experiment on this. And our experiment was that let's first build a standard, one of these simple first robots that a college or school kid will make using an Arduino platform, using a motor driver. And so as you can see, we have to make all these custom connectors. And in case you missed the clock, it was at 12 noon, when she started. And so the real issue that happens is that, I was talking about cash cows. And so one of the cash cows we tried was a workshop. So the first workshop we did was using an Arduino platform. And we failed miserably because there were so many wires, and students got confused, and it took so much time on that it could eventually it didn't really work out. And so what happens is that once you've got into this big jumble of wires, what you will eventually end up doing is make custom connector for each of these. And even if you do that, you will not have enough current to support any of the number of sensors that you're trying to put into that. And so as you can see, almost after 2.5 hours, this is what happens. A very common experience in robotics. So then we did the same experiment with our Speed Robotics Kit, as we like to name it. And we now start at 3. And it's the same kit with 2 motors on the back. And then you take our board, which is this Speed Robotics board, and you plug in. So as you can see now, the motors are just plug and play, and you don't have to worry about the amount of current that they'll take. We can support up to 2 amperes per channel with our motor drivers. Again, IR sensors also, you can just plug on the board. Just 1 and 3 connector goes into the sensor, and the other end goes into the board. And then similarly, you can do that same for a servo motor. You can do the same for an ultrasonic sensors. And it's just been about 15 minutes onto that. So again, the ultrasonic is also supported on the board. And not only that, we can support 6 sensors of each of these different types, and they can all run simultaneously. So in about 20 or 30 minutes, you can see that at least the platform is ready. And then when you get it done in 30 minutes, you usually get this expression. And so you can see, I think this is doing an obstacle avoidance on that. And then you can also do other stuff like maybe line following, which is usually what kids do when they are first in college or school. That's what they're trying to do. However, we're trying to take this to the next level. And by next level, what we've done is we've connected the same board to an Android phone. And let me see if I have that over here. Now, the reason we want to connect it to an Android phone is that if you want to build any advanced robots, you want cameras, GPS, Wi-Fi, gyros, accelerometer, magnetometer, and you know what? All of these are available on a phone. So why not we try using that? So we've created an interface that lets us get data from an Android phone, data of all of its sensors, and we just connect it to this board. And the result is that we're now in process of flying a drone with just using an Android phone and our board. So we've implemented an autopilot software that runs on the phone. It uses its all sensors, camera, and then you can even control the UAV through another Android via Wi-Fi. So as you can see this data, this is the kind of data that we just extract and connect to the board. So that's pretty much my talk. And my conclusion is just that it's a great time to be in this industry if you want to be a Robo-preneur. There's a lot of stuff that can be done. Just remember the idea, team, execution, and the 3 Fs. Don't think about the big investors right now. So if you have any more questions, you're welcome.
So I suggest that we thank Akash now, and it's a good opportunity for people who have other appointments to leave.
Yes.
And those who want to continue the discussion with more questions can continue.
Thank you.